I love your thinking. Okay, let me do one like that. Hang on, just like it. Hang on 1 second. I'm going to give you part B. So suppose I have negative infinity to 0 of 6 over x squared plus 1 dx. Let's do that one first. I like it. This is arctan, isn't it? 1000%. So if I pulled out 6, I'm making a new example. Right, guys? You see that? Do you guys see why I'm making a new example? It's slightly different than the first one we put up. You see the slight difference, right? So when we see this, what is the antiderivative of 1 over x squared plus 1? It's arctan. Okay, but before we can do anything, there is a first step. So I just wanted to show you how we're getting that arctan, right? But before we do anything with an improper integral, is we have to stop and we have to say what is causing it to be improper, and let's fix that by putting a variable in that spot and writing it as a limit. So on your test, you will be required to take and rewrite. So this was just your thought bubble. Sorry, let me get this out of the way. That's our thought bubble. The very first step you'll have to do is you will have to rewrite your improper integral as a limit in order to make your integral defined on finite values proper. And for this case, negative infinity is my issue. We were putting in the letter T. You can also put in a letter A. You can put a letter B. You can put whatever you like. I switch it up every semester. I tend to. But we were using T. And so what we do is we find that problem child, that issue, and we replace it with a variable, and then we take the limit as that variable goes to whatever the issue is. That's how you rewrite your limit. You get points for just doing that, okay? So make sure you can go from there to there. Now we're going to evaluate. Once you get the limit, once you rewrite it into the limit form, then you're going to evaluate. And if you're not writing, yeah, Alex, ask away. Question? You need a pen. Let's see if this one works. Oh, this one might work. How long it'll work for you. Try that and see.
This one? It might be better than a Sharpie.
Oh, you're right. I just gave you a Sharpie, which might go right through your pen. Jenny, you're so prepared. Thank you. That was very kind.
Thank you.
Uh-huh. Alex, you told me that 1 over x squared plus 1 is arctan. So the antiderivative of 6 over x squared plus 1 is 6 arctan. And then we plug our limits in. I like this problem, actually. Limit as t goes to negative infinity of 6 times the arctangent of 0 minus 6 times the arctangent of t. Ooh, arctangent of 0. Guys know what arctangent looks like? I just did that with all of my Calc 1 students. Guys, remember what arctangent looks like and what the limit is? You can say no, no, yes. Anybody remember what arctangent looks like? Somebody's got some things. What does tangent look like? Do we know what tangent looks like? It's the S, right? So arctangent does what? It goes on its side, right? Some people know. Let's pull up a graph. Let's pull up a graph. Let's go to a graph. Arctangent of x is a sideways kind of tangent, right? It kind of goes this way. So the arctangent of 0 is just 0. The angle where the tangent is 0 is at 0. And as you go to negative infinity, what's the arctan of negative infinity? Where's it heading? Yeah, Griffin. Negative pi over 2, absolutely. Absolutely. When you graph inverse trig functions. Oh, it didn't work. Why didn't it work? Huh. Wonder why it's not going. Yeah, it's not working. Not sure why it's not going, but that's okay. I'm not sure. It doesn't matter. But negative pi over 2. Absolutely. These become radian measures because these are angles versus the other way when you have a regular tangent function and it's heading to negative pi over 2. That's the arctan of negative infinity. So we've got that 6 arctangent of 0 becomes 0. We've got that 6 arctan, negative 6 arctan of negative infinity is negative pi over 2 times negative 6, and that's just giving us a final answer of 3 pi. When we have an improper integral, and when we get a finite answer, do we say that this thing converges or diverges? Converges. Awesome, 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 awesome. Converges.
On our test, can you, like, let's say I get the answer.
Uh-huh.
Right, converges for that
Oh,
answer.
I'm just going to have you circle. On the test, I'm going to give you converges, diverges, circle 1.
Okay.
I'm going to lay it right out nice. Yep. Cool. That's the B one we added in. Let's do A. Who's got A for me? What should we do on A? We'll do this one together, and then I'm going to give you some tricky ones from the homework. Did anybody do all the homework on improper integrals? Oh, cool. Okay. Well, let's do this one here. Alex, go ahead. What makes this different? Can you tell me what makes this one different?
It's that 1x, but you can fix that by, what's it called? Integration by parts.
Okay, I like your thought process. You are thinking, I've got a product, x times 1 over x squared plus 1, right? And integration by parts is a great thing to use when I've got products. I want us to go simpler. Give me a simpler method than integration by parts that we might be able to use there. U sub? U sub, do you see? Try U sub. Try U sub on that for me. Let's try a U sub. I like how you're thinking, though. I do. I like how you're thinking, okay, let's pull up our methods and everything. How about a U sub, everybody? Is that what you guys see with that one? So on this one, I'm going to consider a U sub. But before I even do any method, what do I have to do? I have to make it into a proper integral. So we are going to get rid of our issue, which is a negative infinity. So everybody should be practicing writing this out. There is something called muscle memory. Did you guys know there's something called muscle memory? There's something called muscle memory, which means as you do things over and over again, your muscles start to do it without you even thinking. I'm telling you, it just happens riding a bike, right? It takes a long time, then you ride a bike, then you go, right? Playing instruments, driving. Things happen as we muscle memory. Calculus, believe it or not, has muscle memory attached to it. So the more integrals you write, you just do it without thinking after a while. Okay, guys got me an answer here. You're like, Tina, this is way too slow. You guys are doing a U sub. You're letting U equal x squared plus 1, du being 2x dx. 1/2 du is x dx. And so I'm going to replace this. Now we've got an issue. I'm changing from x's into u's. So I cannot keep 0 and t, okay, because those belong with x. So I don't want to see them on your limit when you change. Are you with me? So you either change your limit values or you put little bubbles there or you leave it blank. So you either put bubbles there or you change your values. I'm going to do both for us. Let's see. If I want to change my top, I'm going to take 0 and I'm going to substitute it in for x over here. And that's going to give me 0 squared plus 1, which is just 1. I now have a new top limit. If I'm going to change my bottom, I'm going to put t squared plus 1, and that's going to become my bottom limit. And this is going to be negative 6 times 1/2 times 1 over u du, which very quickly I see evaluates out to be -3 times the natural log of the absolute value of u from t squared plus 1 to 1. If you take the route of changing your limits on the test, okay? Again, if you're going to do a u substitution, I do not want to see 0 and t matched with u. Do you guys hear me? I will take off. I'm telling everybody, okay? So you either switch your limits or you put bubbles or leave it blank all the way back until you resubstitute and put x in. Now, I don't have to resubstitute because I went and changed my limits using my equation for u. And so now these go directly in for you. And let's see what's happening. I've got the limit as t goes to -infinity of -3 times the natural log of 1 minus plus the natural log of t squared plus 1. Natural log of 1 is 0. Thank you, Anand. Natural log of 1 is 0. Natural log, well, let me see. So what is the natural log of -infinity squared plus 1 absolute value? Or in other words, we're taking the natural log of infinity. Griffin, what is it? Infinity, thank you. Absolutely. So what happens with this? Who wants to help me? Kyle. It diverges. We say that this integral diverges because the limit was not a finite value. It did not converge to a finite value. It diverged. What does that mean? If I was to look at this picture under this graph, between this graph and 0, I would see that that area underneath just grows and grows forever and ever and ever. Whereas with this one, it actually converges.
How do you know that one actually converges?
Because it went to a finite value. Here, let's put them up. Let me show you them. Let's see if maybe we can just see by looking at them. The first one was 6x divided by 1 plus x squared. That was the first one. Okay. And so what we're asking ourselves, and we were looking for the area from -infinity. Let me see. What were we looking at? We were looking at the area from -infinity to 0. So we're looking at the area from -infinity to 0. So we're looking at this space that's bounded between this curve and the x-axis. We're measuring that space and seeing, is that a finite value? Okay? And versus 6 divided by 1 plus x squared. Versus this guy, the blue guy.
You know the top one is negative.
Oh, they both had to be negative,
That's
huh?
the first one.
I think, isn't this, did I not do that with the second one? Oh, okay. Oh, I didn't. Okay. All right, let's try that again. So see the red guy? I'm so glad you asked, Alex. Do you see the red guy versus the blue guy?
Yeah.
Do you see why the area under the blue guy, that you see what I'm saying? Why that might look like it converges to a finite value versus the area under the red guy? Can you see why? Because why? Because the blue guy gets closer to 0 so quickly. Do you see that difference? Do you guys see what I'm saying? So why this improper integral for the red, remember we're measuring area underneath, but with the red guy, that's going to diverge. Even though it's getting us, going closer, it still diverges compared to the blue. Does that make sense? This concept is critical when we talk about series. Who's my engineers in here? You guys, any electrical engineers in here? You guys are going to be working with Fourier series a lot, and the theory is based with this improper integration idea with converging and diverging. So, okay, that being said, do you guys see the picture? Do you see the integrals we did? Kind of. Okay, so now I have problems for you guys to try. Are you ready? All righty. Here we go. I'm going to give you two integrals. Both of them have e in them. Are you ready to try it? If you want to pull out your computers, both of these problems are on your homework. Or you can just take your notes. It's up to you, however you want to do it. That way you have an example, so when you go to do your homework, you know how to do these. So here we go. So 2 problems from our homework. First problem is this. 4 to infinity, x e to the minus 5x dx. Second problem is 0 to the natural log of 2 divided by 9, e to the minus 9x over the square root of 1 minus e to the negative 18x dx. I thought I'd save you probably a good hour and go over these with you. These are a little tricky, okay? Like it. That second one, I'm going to give you a little hint here. E to the negative 18x can be thought of as e to the negative 9x squared. So that's my hint for the second. See, let me put up my steps and see if you guys are at the same level I'm at, or it's the same place. So you're going to put a value in, a variable to replace our problem, which is infinity. And then you guys told me use integration by parts. And so you're going to let u equal x. Ilate, inverse trig, logarithm, go through that whole step. It's been a little bit, but then we've got negative e to the negative 5x. V is negative 1/5 e to the negative 5x. So when you go to replace back, everybody should be getting something like this. Negative 1/5 x e to the negative 5x plus 1/5 e to the negative 5x dx. So everybody should be getting, let's see, negative 1/5 x. Now I'm going to rewrite this as e to the 5x on the bottom, just because I have to take a limit, and so I'm just going to set myself up early. Negative 1 over 25. Ooh, well, I'll just leave him here for a second. We'll put him in afterwards. Oh, I ran out of space. Darn it. Negative 1/5, negative 4/5 e to the 20 minus 1 over 25 e. Tina, you're skipping too many steps. Tina, you're skipping too many steps. See if we're doing that right. Is this what you guys are getting here? So you took the antiderivative, and you should get negative 1/5 x times e to the negative 5x, which I just wrote as 1 over e to the 5x, but you should get that, plus negative 1 over 25 e to the minus 5x. You substitute in t, and it gives us negative 1/5 t, 1 over e to the 5t, or e to the negative 5t, minus 1 over 25 e to the negative 5t, or e to the 5t on the bottom, plus 4/5 e 1 over e to the 20, plus 1 over 25 e to the 25. I'm going to stop right there and see if there's any questions. Did I mess up or make a mistake? Because I make mistakes all the time. Ask Jenna. I gave her incorrect information on her homework this weekend. I hope that didn't cost you too much time. I feel so bad.
Only 50 attempts.
Oh my God, 50 attempts. Oh my God, okay. Don't ever email me with questions. How are we? Are we good to hear? So now, we have to take a limit as t goes to infinity. And this is where it gets tricky. This is the one that's the tricky part. This one, not so much. This, not so. These guys are easy because they're constants. So as I take a limit as t goes to infinity, that's going to leave me with 4 over 5e to the 20th and 1 over 25e to the 25th. So those are okay. Where does this guy go? Well, as t goes to the infinity, it's going to give me e to the infinity on the bottom. Yeah.
Both of them are e to the 20.
Oh, maybe they are. Oh, they are both e to the 20. Thank you. Oh, good, 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 good. You caught my mistake. Good, good, good. Not intentional. I know there's teachers that make intentional mistakes. I should just say I make intentional mistakes, but nope, I just make mistakes. There you go. Cool. Now this guy, I'm putting infinity in, and this sucker's growing really big in the bottom, right? So 1 over something really big, the whole thing goes to 0. So that expression is going to 0. So he's dropping out. So the only question left is, what is the limit as t goes to infinity of negative 1/5 t over e to the 5t? You notice when you plug infinity in, you get infinity over infinity, right? What is this limit? Is it 1? Is it negative 1/5? Is it 0? Is it infinity? What is it? Have you guys encountered this in a previous calculus class by any chance? These limits. They're called indeterminate forms. There are different ways to deal with indeterminate forms. One of which is called L'Hopital's rule. How many of you guys have ever heard of L'Hopital's rule? It's a French guy. So one way to deal with situations like this, where you get an indeterminate form. Infinity over infinity is indeterminate. Why? Because it could represent 1. It could represent infinity. It could represent 0. We've got issues, okay? So L'Hopital's rule would say we take derivative on the top and we take derivative on the bottom and we go forward. I don't want to teach us L'Hopital's rule right now. Instead, I want us to look at these two things and just think about this. As t goes to infinity, well, slow down, Tina. Slow down. I want us to use our brains for a second. If I did something like this, which we're going to do not too long from now. If I have an infinite limit with a polynomial divided by a polynomial, what did you guys do to get those limits? You're asking yourself, what happens as you go to infinity for this expression here? Do you guys remember? What we did was we looked at the highest degree on top and the highest degree on the bottom, and we compared them. Okay? We said, this is insignificant. 1 is insignificant compared to infinity. So 5t over 2t are the two pieces that make any difference. And so what we did, I don't know if you ever remember doing this, was you looked only at the numerators and you came up with these rules, like if the degrees match on top, it's equal to this. If 1 degree is bigger than the other. Do you guys remember those rules from pre-calculus? You can say, no, Tina, I have no idea what you're talking about. But I want to tell you the theory here and see if this doesn't make sense, that when you go to infinity, if you just look at the highest power on top and the highest power on the bottom, that gives you a clue what's going on. So if I look right here at t on top and e to the 5t, and I compare them, which one grows faster? Which one gets bigger really fast? They both go to infinity, right? T squared goes to infinity and t goes to infinity, but which one goes to infinity faster? T squared. In fact, if I was looking at t squared compared to t, that limit would be infinity. T squared, are you with me, guys, kind of? Same thing, e to the 5t. E to the 5t is an expression which grows infinitely big really fast because it's an exponential function. T is a linear function, has linear constant slope behavior, okay? E to the 5t does this. In fact, it goes even faster. So if I'm comparing t versus e to the 5t, and I'm moving to infinity, which one is going to grow infinitely big, infinitely faster? It's this guy, okay? Are you kind of all with me? Which means I'm going to have something divided by something that's growing even bigger. And so we are going to assume that this limit is 0. Ooh. It is. It is. Right here. Yes. Yes. Like this, right, Anand? So I brought it down so I could look at it. So what's happening is we've got a little infinity divided by a big infinity. This thing is going to 0. If you guys prefer to use L'Hopital's rule, you would take the derivative on top and the derivative on the bottom, and you would also get the same conclusion as t goes to infinity. Derivative on top is 1. Derivative on the bottom is 5e to the 5t. That whole thing goes to 0. What I want you to start recognizing is the difference between what is happening with the growth pattern here. This grows much smaller than this. One other way, what could we do to look at this limit? We could graph it, and I think you guys all have Desmos. So the other way that you could look at this, I know I'm giving you so much information. I'm giving you too much information. I think I'm giving you way too much information. Have I insaturated your brains? But I will tell you, you know me, I like pictures. I really like pictures. I like graphs. So personally, my favorite way to evaluate a limit like this would be to graph it. If you could graph it. But for some reason, my PC is not working. So... Well, I can't seem to get my graph to work. For some reason, Desmos turned off on me. The other way would be to graph this thing. Look as you go to infinity, and you'll see it goes to 0. So you would be able to say this thing goes to 0. This piece goes to 0. This piece goes to 0 because e to the 5t grows infinitely large compared to t, because of L'Hopital's rule or because of the graph. And therefore, this limit here is simply going to be 4 over 5e to the 20th plus 1 over 25e to the 20th. And we could put those together, or you could leave it like that in WebWork. Either one works. Okay, guys? That was way too hard. That was way too hard. You guys don't care about this. I can see that. I can see glaze on the eyes. This one's fun. If you're a mathematician, the next homework problem is fun. Do you see that natural log e to the negative 9x 1 over e to the negative 18x? I need a whole new sheet for this one. You're like, Tina, I'm just done for the day. No more improper integrals. But let's do this one out, just because if you're a mathematician or if you're a math student, you'll like it.
Negative 9x squared, wouldn't that be positive 18x?
No, because we have power rules. Thank you for asking that, Munia. Thank you for asking that question. Guys, I gave you a hint that e to the negative 18x is e to the negative 9x squared. And the reason is because we have exponent rules. that say things like if you have x to the 3 to the 2, that's actually x to the 6th, because what we do is we multiply our exponents. So negative 9 times 2 would give me the negative 18. Are you with me? So I was suggesting that we rewrite this guy as negative 9x squared. But before we do that, guys, before we even do it, well, we could rewrite, that's no problem. But before we do any kind of evaluation or integration, what are you going to be looking for? You're going to be looking for a place where we get some kind of a problem. Now, it's not infinity or negative infinity, which means there has to be a number in here which is causing my denominator to equal 0. What's that number? Is it 0? Why is it 0, Anna? E to the 0 power is 1. 1 minus 1 is 0. This is my bad guy. This is my bad guy. So the very first step on your test will be rewrite this as a limit, right? So we have to address the fact that this is the bad guy. Why is it the bad guy? Because e to the 0 is 1, and that means on the bottom, I would just have the square root of 0, which is bad. So rewrite this as a limit to start. You're going to send t to 0, but hang on. Somebody help me out here. Am I just going to 0? I'm not going from both sides. I'm going from which side? Yeah, which side? So I'm going from 0 to natural log of 2 over 9, which is a positive number over here. So that means I'm coming from the positive side. So I'm coming from the right. Right? Because 0 is here. Natural log of 2 over 9 is here. And if I'm talking about within this interval, I am approaching 0 from the right side or the positive side. Hence, I'm going to 0 from the positive side. E to the negative 9x over the square root of 1 minus, and I'm telling you, rewrite this like this. Do you see why? Do you see why? What are you going to do with that? Make a what? Huh? U sub. Absolutely. What are you going to let U be?
1 minus e to the
Could be. Uh-huh. Even better. Think, oh, you could. Actually, you have to be careful with that. Squared times the derivative of this. Or minus 9x. Just let it be e to the minus 9x. We are absolutely doing a u substitution. You are going to let u be e. You're going to let u be e to the negative 9x. Chris, did you do it how I read it for you? Okay, good. Okay. How are you guys? Good? Make that mean is. Oh, yeah, what is it? It's something. It's absolutely something. It's a something. It is a trig. It's a trig. It's a trig. Well, we could do trig substitution, or we could know that it's an inverse trig function. It is a trig substitution. I like your brain. Or it's an inverse trig function. What is that inverse trig function? Square root 1 minus u squared. What is that trig function? You're going to have a chain rule problem. That's why you'll have a chain rule problem. Although, actually, you don't understand. You were learning kids. Oh, you don't even need to think of it as e to the 9x squared.
Oh, wait,
Huh. Dang it, don't ever listen to me. I mean, arc, don't get me wrong, arc sine is good, but
would it be?
hang on, what's gonna happen here? That's gonna give me E derivative du. I'm doing your way, Paul. Let me see. That's 18 E. Oh. 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 That's why we can't do it that way. Because in the numerator, we just have, we just have that. We just have that. Whereas when I take the derivative, if I leave it, when I take the derivative, I get e to the minus 18. They're not gonna match. That's my problem. That's my problem. Yep. Okay, how are we? Got an answer? Did it converge? Oh, I'm so sorry. I'm sorry. Did it converge? Sorry. Did it converge or diverge? What'd you get? Did it converge or diverge? Did you get arc sine? What's making this hard, guys? You're just letting me do it, aren't you? Huh? Yeah, sure. Uh-huh. Get our brains going. Get our brains going. A little bit of adrenaline, a little bit of fun. When somebody gets an answer, go. So I think most people are getting this. Some people are getting an answer. Let me run down the steps here. If you do a u substitution, you're going to let u equal e to the negative 9x. The derivative is negative 9, e to the negative 9x dx. And if I change my limits, my top limit becomes e to the negative 9 times the natural log of 2 over 9. And my bottom limit becomes e to the 0, which is 1. This guy right here looks like it's kind of messy, but not really because the 9's cancel, which leaves me with e to the minus natural log of 2. And I know there's a logarithm rule that allows you to take that negative and move it up here as an exponent. And I know that e and ln are inverse trig functions, and therefore my top limit actually is just 1/2. So if I was to do a u substitution and change my limits, I would discover that my new limits are, oh wait, where did t go? Oh, 0, yep. Wait, Tina, slow down. Big mistake, this is t. My bad, this is t. This is t. Ha. My bad. I was going too fast. This is 1/2. This is u. Nope. Undo, Tina. Slow. 1 minus u squared du. That gets replaced with du. That is the limit as t goes to 0 from the positive side. E to the t, 1/2, 1 over the square root of 1 minus u squared. That is arc sine. That's our inverse trig function. Did you get arc sine, Anna, by using trig substitution? Nice. Griffin, question.
Wouldn't the bottom limit be e to the negative 9t?
It is e to the negative 9t. Oh, my God. Okay. Yes, it is. Thank you. Thank you kindly, sir. I'm going to start going slower. When you plug it in, you guys are obtaining arc sine of 1/2 minus, let me make sure I'm doing this right because I got a wrong number, but let me see. My original limit is ln of 2 over 9. I'm substituting, and I get e to the minus 9 times the natural log of 2 over 9. The 9's cancel, so I'm left with e to the negative ln of 2. That's equivalent to e to the natural log of 2 to the negative 1. And that's equal to 2 to the negative 1 because e and natural log are inverse functions. That's equal to 1/2. My top limit, if I switch my limits, becomes 1/2. Excuse me. My bottom limit was t, but I'm simply putting it here in place of e to the minus 9x. So it is e to the minus 9t. Everything's perfect. Yes.
Negative 1/9 for the arc sine.
Do I have a negative 1/9? I'm sure I do, Anna. Yep, I do. Thank you.
That's what I was asking.
Oh, that's what you were asking. Sorry, Kyle. Holy moly. Ay, ay, ay. Thank God I'm not taking a test today is all I have to say. Oh, my goodness. It is another one of those days. Okay. I am so glad I have a zillion eyes. Thank you, guys. And I bet you're so glad we're doing this homework problem in class. Arc sine of 1/2 says, at what angle on our unit circle is sine equal to 1/2?
Pi over 6.
Pi over 6, absolutely, 30 degrees. So that guy is pi over 6. As t goes to 0 from the positive side, I'm looking at what happens to 1 over e to the 9t. Well, as t goes to 0, that's 1 over e to the 0, which is just 1 over 1. So what I'm looking for here is the arc sine of 1, right? At what angle do I have sine being 1? That's what's inside here. So I'm actually looking for the arc sine of 1. So I have negative pi over 54 plus, what's the arc sine of 1? Pi over 2, right? Sine is 1 at pi over 2. So that's going to give me pi over 18. 18 does go into 54 3 times. No, it doesn't. Hang on. Yes, it does. 3 times. So that means that's negative pi over 54 plus 3 pi over 54, which is giving me 2 pi over 54, or pi over 27. Match you, Nate? We would say that this improper integral converges. In this session, so that if you miss any part, you can always look back at it for these homework problems. The problem that we did was this guy right here. 22 over 2x minus 1 times x minus 6, 7 to infinity. Did anybody finish this by any chance? Oh, you did. Did you get all the way down?
I know that it's ends at infinity that terms. I don't know if that's right.
Almost. You get so close. I actually get infinity and infinity. Let me see if I get what you get. Let me see. So, we started this last time. We didn't get very far. We looked at it, and the first thing we did was we rewrote it. We rewrote it using limit notation. So I do believe we got this far last time. We took t going to infinity and we wrote 7 to t of 22 over 2x minus 1 times x minus 6. I think we did get that far, right? I think so. And then we stopped, I think. But I did say that we can solve this using partial fractions. Can you start by getting me at least solve that integral down using partial fractions? And then we'll talk about the limit, okay? We'll take 5 minutes to do this, and then I'll tell you about the p integrals. Four and two. Plus 2, did you say? Over x minus 6? So that's going to give me 4 plus 4, which is going to give me 8x minus 2 minus 25. I don't know if that's the right numbers. 4 for on top of 2x minus 1?
This is like the nice, you separated into the two integrals. So that's
No, no.
4.
What I'm saying is I don't know if those are the right numbers,
Oh.
Kyle.
I got
Because-
negative 4.
You got negative 4? You got negative 4? Negative 4? Negative 4? Okay, good. You see, I was just making sure those numbers were right to start with. Okay.
That's
Okay,
probably
good.
where I got the positives.
Ah, yes.
There.
Yes. So you guys are doing partial fractions, right? Everybody's working out these partial fractions. So I'm going to just do my think bubble here. A over 2x minus 1 plus b over x minus 6. This has to equal 22 over 2x minus 1 times x minus 6. I'm purposely, guys, challenging you in class to work things, to remember things, because your final exam is a cumulative test. So the more that we go over problems like this, I know it might not be fun, but the more we go over this, right? Oh, nice. Now, when you went from here to here, no more integral, right? No more integral. Yeah. So what do we get here? A lot of people are a times x minus 6 plus b times 2x minus 1 equals 22. If we let x be 6, that means I have b times 11 equals 22, or b is 2. If I let x equals 1/2, then that means a times negative 5.5, which is negative 11 halves equals 22. So a is negative 4. Yep, I get at negative. So I do. I get negative 4 there too. So t is infinity, 7 to t of the two integrals, negative 4 over 2x minus 1 plus the integral 7 to t of 2 over x minus 6. Okay. So we got a limit as t goes to infinity of, okay, Tina, natural log, undo, negative 4 natural log of 2x minus 1 plus 2 natural log of x minus 6 from 7 to t. Let's see if you guys are matching me. Minus 4 natural log 2t minus 1 plus 2 natural log t minus 6 plus. Did I make a mistake?
In front of the first natural log, would it be minus 2 to negative 2?
Oh God, yes! Oh God, yes! Oh God, yes! Thank you! Thank you! Absolutely! Oh my God! Okay, I am telling you, today is not my day. Holy moly! I just want to go to bed. That's all I want to do is just sleep all day. Who wants to go sleep all day? Absolutely. Ay. Tina, you are having, yeah, I'm with you. I got up at 3 o'clock this morning. I don't know what my problem is with sleeping. Okay, alrighty. Why is there a 2 there? Of course there's a 2 there, because when I do my U substitution and go to my natural log, I did the number 1 error that I would take off on my own test if I did this mistake, right? There's that extra factor of 2 that has to come in front. Okay, thank you, Kyle. Thank you for whoever told me that. Thank you. Okay, so now let's see if that's good so far. So now I've got minus 2 ln of 1. That's 0. So this is the limit as t goes to infinity of minus 2 natural log of 2t minus 1 plus 2 natural log of t minus 6 plus 2 natural log of 13. And please verify, Kyle, am I good there? Lilia, am I good there? You guys good? Are we good? Brandon, are we good? Did you get an answer there? Now, what is my problem? Where is there a problem now? The whole thing. Read, where's my problem? Right here, right? What's my problem? When I plug infinity in, you guys see? Dan, are you with me? When I plug infinity in here and here, it gives me negative 2 times infinity plus 2 times infinity, because the natural log of infinity is infinity. I have a negative infinity plus a positive infinity. This is another one of those weird limits that you don't know what to do with. So, y'all with me? Do I have 10 minutes, 5 minutes? 5 minutes? Give me 5 minutes? Or no, am I done? 13 minutes? Okay. Put these together using logarithm rules. I know. Tina! No more. My brain's done. I'm in calculus. I don't want to remember logarithm rules. Absolutely don't want to remember logarithm rules. Step number 1. You could factor out a negative 2 or a positive 2. Let's just take out negative 2. If I take out a negative 2, then I'm left with 2 logarithms, right? I have just expression here. But I'm just saying this is A, this is B. But if I factor out a negative 2, are y'all with me? Then I have, what? ln of something minus ln of something. What is that rule that puts 2 natural logs together? Do you guys use this at all in any? It's a division. It's the division. A over B. So really, this can get combined to give me an expression. Yes, 1000%. So let's put that together. My first suggestion is factor out a negative 2. But before I do that, let me explain again for people that are watching. The problem that comes up right here is I get this indeterminate form, negative infinity plus positive infinity. That's a bad limit. So we are going to challenge ourselves by putting those 2 together using a logarithm rule. I suggest we factor out a negative 2, leaving us with a natural log of 2t minus 1 minus 2 natural log of t minus 6, and then putting those 2 together. So minus 2 times the natural log of 2t minus 1 over t minus 6. By the way, the math department picks your homework problems. I'm just going to let you know. I didn't pick them, okay? But I help you get them through, get them done. Now you're in a good space. Why are we in a good space now? Because now we can look at these guys right here. As t goes to infinity, we're going to use that idea that you just look at the highest power on top and the highest power on the bottom. Okay? We're going to look at that using that thing we talked about a minute ago. I've got 2t on top. I've got t on the bottom. If I was to look at that, that would reduce down because I'm cheating a little bit, but not really, because the highest degree is what actually determines the behavior as you move to infinity. So actually, this is going to go to minus 2 times the natural log of 2. And then I have plus 2 times the natural log of 13. That's the behavior that happens as I go to infinity. That was completely sloppy work, Tina. You were so sloppy. You were so sloppy. Let's try that again. I am focusing in on this limit right here. I already know what this part is over here. Hopefully you guys are all agreeing with me and getting the right thing. This, as t goes to infinity, just goes to the natural log of 2 plus 2 times the natural log of 13. We would say that this integral converges. And that should be the answer that WebWork takes. I see that area is infinite. Well, I don't know that area is infinite, but I see that I'm going to infinity, so I have an improper integral. Looking at the pictures, can you tell me which of these areas you think are going to converge versus diverge? And we're only going out to 8 units or 9 units right here. We're not going to infinity, right? We're only going out to 8 units. We're not going to infinity. But which of these areas would you think, are you with me, are going to converge? What would be the logical thinking? Griffin?
The top one.
The top one absolutely looks like it's going to converge, the area. Can you see why? And this guy, maybe, not quite sure, but this guy, probably not, right? I will tell you that this integral does converge, and this guy diverge. I'm going to write that down. And you can solve this out very easily, because these integrals are like easy peasy integrals. You know what I mean? Like what's the antiderivative of 1 over x squared? It's a negative 1x to the negative 1. Plug in infinity. You see what I'm saying? These guys are all very simple to come up with these answers. There is a quick rule for p integrals, and I do want to share that with you because I think you have a homework problem, and I put it here because you're going to need this idea again when we hit series. But here's the point. The cutoff point is the value 1. When your power is 1, that is actually what we say is our cutoff. If your power is anything bigger than 1, then it satisfies the condition that when you take the antiderivative, you'll get something that converges. And I challenge you, if you like math, any of my actuarial science math majors, math ed majors, education majors, I challenge you guys to go home and understand why this becomes a cutoff, why this is a break, why integrals that have bigger powers converge, and those that have smaller powers, like 1 and a half, diverge. Look at the integrals. Work a couple out. It won't take you more than 5 to 10 minutes, but look at those patterns and see why that's true. But the rule is this. If p is less than or equal to 1, your integral diverges. We looked at the picture, right? We saw it doesn't look like that area goes finite. If p is greater than 1, this integral will always converge. This is true for any p. And the integral 1 over x to the power. Okay, guys? So like I said, I challenge anybody that enjoys math, just do out a couple of them. Pick p being 2, p being 3, p being 1. Notice the difference. Why is it doing that? Why does it converge versus diverge mathematically with the integration part? But I don't want to talk any farther. I want to let you guys go discover that if you're interested. If you're not interested,